Go. So first of all, the probability of if we on tree diagrams, the point at which, I guess, the junction where it branches off, it's saying if there's two junctions, then we're saying there are two eventualities of whatever. So in this case, we're saying Kevin is taking out a random counter. That's what he's doing here. Okay. And Kevin then takes out a second counter, which is what he does either here or here. And what if you follow a path like here and then all the way to here, then that's saying that he picked out a green counter, then he picked out a green counter again. So if there's only two options, and then that's the probability of him picking out a green counter, then the two probabilities must add up to 1, because if there's only two possibilities, then the probability of any of them happening must be 1. The total, it's either this or that. It can't be anything else, because that's what the probability tree is telling us. So in other words, if the probability of him picking a green is 7 out of 8, then it must be 1 out of 8 of picking a blue, right? And the second thing is what happens here, he's going to what's the probability of him picking a green again? It's 7 out of 8 again. Why is it 7 out of 8 when he's just taken a green counter out? Surely it should be 6 out of 7. There should be 7 counters left, right? 7 counters in, and 6 of them, and it should be 6 green left. But the reason for that is because he replaces the counters in this case. Sometimes they don't do that. All right. So you have to. That's what conditional probability will be. Now, in this, if he's going to replace it, it's just the same as the first case. So it's just going to be 1 out of 8 again. And then what's the probability when he picks a blue one? He puts it back, so it's just the same as it was before. So it's the 7 out of 8 chance of him picking a green, and 1 out of 8 chance of him picking a blue. So if it had 8 counters in there, that would mean there were 7 green and 1 blue. If there were 16 counters in there, then there would be 14 green and 2 blue. But all it's saying is he's saying the probability of him picking a green is 7 out of 8, and the probability of picking a blue is 1 out of 8. So what would be the probability of him picking 2 greens in a row? So when we're combining probabilities, saying this and this happening and this happen, when we're thinking about words like and, then we are using, we're going to use multiplication. And when we're thinking about or, we're going to be using add. So I'll demonstrate what I mean. What's the probability of him picking a green and then picking another green? It's going to be 7 out of 8 times 7 out of 8, the two probabilities, right? So have a go telling me the probability of him picking a green then a blue then a green, and then a blue then a blue. So that's the probability of getting a green and a green is 7 times 7 over 8 times 7 over 8. So and is times. So all these, this is green then blue, blue then green, blue then blue. We're multiplying them every time, right? We didn't finish the actual sum of these ones, did we? So this was 1 over 64. And I'm not going to do that one in my head. But get a calculator out and find out the answer to that one. But what's the probability of him getting at least 1 green? What's the probability of him getting at least 1 green? The probability of him getting at least 1 green, what we have to do is we have to think, well, which ones... so we've got these 4 different eventualities, and let's look at each one. I said at least 1 green. Well, green, that one's fine. Green, blue, that one's at least 1 green. Blue, green, that one's at least 1 green. The only chance is this one here. So this one does not fit my criteria when I said at least 1 green. So that means it's going to be this or this or this. So it's going to be 49 over 64. And then what do? You plus them. So 49 over 64 plus 7 over 64 plus 7 over 64. Okay? Right, good. So when you add them all together, it's 63 over 64. Now, there was a shortcut here, but I wanted to demonstrate the OR idea first. You'll notice that the only possibility of him not getting at least one green was him getting this. And we worked out the chance of that happening was 1 over 64, which means that the remaining... So if it's not 1 over 64, then... And it's basically, if it's not this eventuality, it's going to be anything else, which is clearly going to be 63 over 64, because all of these probabilities must add up to 1. And so there was a shortcut there by simply saying 1, take away 1 over 64, and that's 63 over 64. So I guess I've... so basically, or... we just think if we're saying this or that, then we're adding the probabilities, and if we're saying this and that, then we're multiplying the probabilities. Okay, right.